Okay. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuhu. Uh, my name is Mohammed Faisal. I'm the Chief Examiner at Nafi. Today we have with us Arslan Ahmed Arif. Mr. Arslan Ahmed Arif is going for his Diploma in Artificial Intelligence Operations, EduQual Level 6 RQF Level 6 exam for 360 credits. The topic he has is basically implementing Swarm Intelligence platform with bio-inspired algorithms, collective robotics, and distributed decision-making for complex system optimization. This project challenges students to architect and implement a comprehensive swarm intelligence platform supporting bio-inspired algorithms, collective robotics, and distributed decision-making for complex system optimization. The solution must enable emergent behavior, coordination, adaptive learning, and scalable optimization while demonstrating applications in logistics, manufacturing, and autonomous systems. You have to show me, there are some certain key learning objectives. You have to show me bio-inspired algorithm implementation, the PSO and the ACO, just like the particle swarm optimization and the ant colony optimization, right? Subhanallah, like for everything, the human beings, they take inspiration around the things that with which they are surrounded by, right? So ants, the mimicry, their behavior and everything has inspired everything. Allah says in the Quran, think and ponder on the creation of Allah subhanahu wa ta'ala again and again in the Quran, right? So if we start thinking and pondering around surrounding things and the trees, the leaves, the water, the animal kingdom, the insect kingdom, and all of those things, and we will see the marine kingdom, we will see so many inspired things that we can develop using the same mimicry technology, right? Inshallah. So collective robotics with multi-agent coordination, emergent behavior and self-organization, distributed optimization and learning, swarm simulation and modeling platforms, something you have to show me, application and complex system optimization. There are some open source cloud native tools. You have to show me the implementation of Deep, PySwarms, Scikit, Opt, Spade, Mesa, Sumo, as you mentioned. You showed me some of the things, right? But I need to see more, and I need to see the logs, the development methodology, how you were able to execute, so on and so forth, minus the GPU computing. You can show me OpenCL, Numba, like running on some of the things, but of course, CUDA cores requires NVIDIA architecture, right? I don't expect our students to show me CUDA cores because CUDA cores computation because it requires some of the expensive cards. Even some of the basic cards are very expensive, the 3090s and stuff like that. So in the presentation, you'll be given minimum 15, maximum 20 minutes, followed by a Q&A, which is going to be 30 to 40 minutes. The whole exam will be wrapped up within 45 to 60 minutes. So, Arslan Ahmed Arif, are you ready for your exam?
Ji, sir. Yes, I'm ready.
Okay, let me start the timer. Can you please share your screen? Okay, Bismillahir Rahmanir Rahim. You may start your exam.
Assalamu alaikum, everyone. Bismillahir Rahmanir Rahim. Today I'm presenting EduQual Level 6 presentation of myself, which is topic is implementing swarm intelligence platform with bio-inspired algorithms, collective robotics, and distributive decision making for complex system optimization. Well, the statement looks kind of complex. So before getting into my presentation ahead, I just really want to decompose this problem statement, so it is easier for us to understand what's going on further. So first, I would like to highlight the bio-inspired algorithms. Well, basically, bio-inspired means the algorithms or mechanism the technology has adapted from the nature, like the birds flocking in the sea in the sky, like how there is no one leader in their swarm, and there is on everyone have equal rights and they move equally towards their food, like they easily search their food. And when we see the ants, no matter what, they always find the shortest path to their food. And if we see the bees, they they can find the best solution while they have. When we and there's another things, the collective robotics. Okay, collective robotics mean two or more vehicle or boats or anything mechanical can work in coordination in between with them. Like if someone is doing some work and other is doing some work, they can take a decision independently. Like they don't have to wait for the centralized system to give orders for them. They evenly can do actions on them without taking input from the mainframe, any centralized opportunity. And after that, we have distributed decision making system for complex system optimization. This means that after a particular point, each vehicle can easily take their own decision. So in this presentation, I'm implementing a swarm intelligence platform which will be inspired from bio-inspired algorithms, which have collective robotics behavior and can take decision making independently. So the niche I'm choosing is currently for logistics. So this is the presentation flow, that how the presentation will go ahead. First, we will discuss the problem context in logistics area. After that, I will explain the swarm intelligence and its core components. After that, we will discuss some bio-inspired algorithms and see the architectural diagram for development and production as well. And after that, we have industry cases studies. All right, so first discuss the real world logistics problem. Let's say there is a company named A. They have a different depot station in the city, and the customer give orders to them for deliver. And their vehicles in the morning. In the morning, when the vehicles go for delivering the parcels, etc. Uh, when the parcel is getting delivered, let's say some incident happen on the road, one road is blocked and other road some accident happen, or at some part of the city there might be a draining system or something else. So the route they initially made at the start of the day, it will not be valid when if such type of disaster or anything a blockage came into being. So let's say the meanwhile we assume a scenario. Let's say the vehicles on the way, the orders are getting into volumes and volume in the same delivery day. So the system do not have any mechanism to designate a particular order to a particular vehicle which is on the way. And the another thing which is we can highlight from the scenario, the static routing is not working in the dynamic condition of traffic. Let's say if some vehicle is on the road and delivering parcel to another area, somehow the road got blocked and the person have to wait for long or long time. So the system or the person who have to manually calculate the route for itself, maybe it could be very cost effective or maybe cost effective not. So at that point the static routing will fail here. And let's say if someone a person contact to his senior person or somewhere else, he said to demand for new roads. So till that time he will wait for in ideal situation. In that situation, the burning of fuel and the time waste, so order will deliver late. Underutilized fleet and lower competition time. This also conclude to that point. The fleet, the total number of vehicles cannot be used effectively in that procedure. No autonomous learning or self organization. Let's say if we take example as I live in Lahore, let's say on Friday night at 7 p.m., always the Liberty Road and most of the time got blocked. So if the system did not learn from itself, so normally the system assign the orders to the vehicles uh, at 7 p.m. at Liberty Chowk. So if our system get learned, he knows that at 7 p.m. the Liberty Chowk get blocked. So I have to provide him another route to easily place that area to that point. Okay. So, first getting into the Swarm implementation, I would really like to discuss what is swarm intelligence. First, I will read the definition. What is swarm intelligence? After that, I will explain key characteristics of swarm intelligence and the core SI components of swarm intelligence. And I will explain why I have put the key characteristics away and core swarm intelligence components away. And if any thing which shows these characteristics as from this definition we can say is that swarm intelligence platform or not. So okay, first we will read the definition. Swarm intelligence system is a collective emergent behavior that arises from the interaction of many simple decentralization following the local rules without any central controller, resulting in the intelligent global outcomes. This definition becomes more meaningful when we map it to real life. Imagine a busy food court in a shopping mall. Hundreds of people are trying to find empty seats. There is no central assigned seats to each person. Instead, everyone looking around locally checks nearby tables, sees which sides has more spaces, and move accordingly within minutes. The crowd naturally distributes itself. No one planned it centrally, but the result is efficient seating discovered through local decisions, helping at the same time. Okay, from this example, we can highlight some key characteristics which are already proven. The decisions were not coming from a leader, providing the decentralization uh, system of the system. People were reacting based on what they saw, proving local interactions lead to global behavior. The crowd automatically adjusts and distribute itself without manual replanning, proving self-organization and adaptation. Even when the crowd size increase, the system will work without collapse, proving scalability and robustness. If people remember that one corner has always seats, then it will be faster next time. All right. Okay. So these are the key characteristics of the Swarm Intelligence platform. Now we will discuss the core Swarm Intelligence components. The components listed on the slide of the other side. Multi-agent systems means a created decentralization by giving every vehicle or robot its own role. Self-organization and emergence means explain how local interactions turn into intelligent patterns. Stigmery enables indirect communication like following shared environment since node commands, as in the previous example I was telling about the people following the routes without seeing the other people's. Distribute optimization ensures scaling does not get bottlenecks, and learning, which is our route memory, ensure improvement instead of resetting every run. So after some time, our system get learned from that system. And now there is one thing which I really want to clear if from this definition, if any behavior, anything else which shows these characteristics, it really doesn't make it itself a swarm intelligence. We can say that this thing is mimicking the swarm intelligence behavior platform, swarm intelligence, but it is not actually a swarm intelligence. If until unless it have this all core components. If anything in this core component is missing, we can't say that it is a swarm intelligence platform. Because if we remove the multi-agents, then the simple system become centralized. Simple system have to wait for a central command system to give input, which is against the swarm intelligence platform. So if the system does not have self-organization, so disruption recovery becomes very slow. If the system did not have emergence, like the overall system did not get mature over the time, so we are not learning from the past experience, so still the system got failed. And is as well as if we do not include a distributive optimization or learning route memory, so we it will create a bottlenecks for us and system resets everyone, which is against the swarm intelligence uh, rules. Now I would really like to discuss the how swarm intelligence resolves the logistics problems. On the left side, Uh, okay, the table is on the slide is not just a comparison, it shows cause and effect. Every swarm principle listed on the left side directly creates a logistic capability in the middle, which then leads to the real outcomes on the right. The foundation is the multi-agent system where vehicle can act as autonomous agent. In the traditional logistics, if one central system fails, everything stops. In a swarm system, each vehicle can operate independently, share feedback, and adjust decisions. This means there is no single point of failure, and decision stays resilient even when disruptions happens. The benefit is not only independence; it's the resilience by design. The very next principle is the self-organization. When something goes down wrong in city, like accidents or delays, a static system has to repartition all routes again from the center. In swarm systems, vehicle can reassign tasks automatically and reshuffle routes collectively without waiting for the central calculation. This leads to faster disruption handling, becomes the system repair itself in dimension is not in restart. Another important principle is stick memory, which means indirect communication through shared memory instead of direct commands. In logistics, this becomes shared traffic data route quality memory. Vehicles don't need to talk each other directly. They simply follow the highest score routes stored by swarm over the time. This means like let's say if someone is if some vehicle is going from one route to another route, if he face troubles at certain points with the period of time, so the system can learn that these are the edges points wherever the vehicle got issues problems, so next time the system would not recommend it. All right. Then comes the emergent behavior. When vehicle and robots interact using local signals and swarm memory intelligence emerges from the group, the system begins to learn delivery patterns over the time, such as which areas slow downs at what or at what path pattern better for the system performance. This creates gradual improvement and makes a delivery more consistent. Now let's connect distribution optimization. Instead of one machine computing all routes, optimizing responsibility is shared. Every vehicle contributes both its best route and swarm intelligence globally best route calculating in parallel. This ensures scalable and fast decision making even when demands become very high. More agents mean more exploration power, not delay. So this is we can say the one of the best route for the logistic problem. Finally, adaptation and learning add the real layer. The system continues to perform real-time rerouting and performance improvement, which means it can handle new orders, live traffic, weather change, and road condition instantly. This is not a luxury feature; it is a necessary and unpredictable in very cities. Now let's move to some of the bio-inspired algorithms. There are several bio-inspired algorithms, but I will discuss here some few such as PSO, particle swarm optimization, and the ACO and colony optimization, and ABC, which is artificial bee colony. The PSO is The PSO algorithm is basically derived from the birds flocking in the sky. The ant colony optimization ACO is basically derived from the ants, and ABC colonies algorithm is basically derived from the bees which is available in our system. Okay, so PSO, which is as particle swarm optimization, works like birds moving toward the best direction. In logistics, every vehicle checks its own best route and group the best route, then adjust itself. This makes PSO a fast baseline solver for the VRP vehicle routing protocol, which helps assign to orders quickly while keeping route explorative and active. Next, we have ACO, which is ant colony optimization. It is inspired from ants, leaving trails for others to follow. So in logistics, these trails become shared route sources in memory, helping vehicle choose shorter, smarter paths even traffic changes a lot. Next, we have the ABC algorithm, which works like beaks, where we use good routes and scout search for new ones. In logistics, ABC helps system repair routes during mid-run disruptions and avoiding getting stuck on a bad path. Let's say our vehicles are on the way for delivering, and meanwhile, my urgent order came into place. And instead of calling a vehicle to that position, I will dynamically allocate the uh, parcel to the nearby vehicle. Now we have two architectural diagram for this implementation. One is for development and one is for production. why do I choose why do I prefer to choose two architectural diagrams? Because first we have to see like how we can mature this solution in the development mode. After that, how this architecture will go in the production environment. So on the left side, I have simulation environment. On the right side, I have the core mechanism of swarm intelligence, in which each algorithm is working as a microservice in this environment. There we have the database service, and here we have our machine learning stuff. So in simulation environment, I will use Sumo and Tracy. Why I use Sumo and Tracy? Because when I have to validate this implementation, I have to first check it on a development mode. And in development mode, I really need some thing like mechanism in which I have to test real time scenarios like road blockage, traffic stuck, anything change in environment, or any construction work is happening. So for that purpose, I use Simo, which is a simulation tool, and with Tracy to make communication with each other. And here we have the synthetic order, like the artificial order, to test our cases, like in that scenario what happened, and in that scenario it happened. Uh, and here we have the COMS core swarm microservices. Here we have all services which have their coded program, such using PySwarm's library, which have the algorithm implementation in real life for PSO, ACO, and other thing. Uh, uh, okay, so how this platform works? Initially, we will trigger some synthetic orders from there. We will get response from the Sumo, like the real life scenario. From there, it will go to the event bridge, and it will trigger as an event that this order has happened. And from there, it will trigger our core swarm intelligence microservices, which will give us the best route for that particular use case. And for that route, from there, we can store the logs in the DB, such as we are using Aurora, and S3 we are using for save its logs, which help us to analyze best thing after that. And here we have the learning and policy evaluation maker. From their logs and from their data, this we are using Amazon SageMaker. After that, it will conclude. From there, we have connection to this learning policy. So next time, when this route happen, or if someone facing that issue, he won't able to see that again after the system get mature. So this is the production architecture diagram. In this, I am using the convention, let's say the multi-tenant application, in which each user have its own organization, and from there he can access his account. All right. So here we have users. The users can log in into the company via. First, I will explain the architectural diagram. Here we have the uh, user interface, from where the user, how can they access the application. Here we have the vehicle related thing, like how vehicles share information with each other, and how they can make decision even the system goes offline. And here we have the again something related similar in the dev environment, the core microservices for the swarm intelligence, which will be hosted on Amazon EKS on Kubernetes platform. Okay, so we are using AWS Cognito mode for the user to get authenticate into our platform. We are using CloudFront for their easier accessibility. So we will face some sort of latency in our application. This is the admin panel, we can say. And here the vehicle. In each vehicle, we have some IoT devices, and they will communicate with our system through MTT protocol. Like they will share the nearby roads, the situation, the traffic stuck, or even they can ask reroute when their system happen. And from there, again, as same like in the development mode, the system communicate with the EKS clusters. For each algorithm, we have some EC2 running in Docker containers, and the ECAS will be managing them for us. And here we are using a database service which store our logs and data. And here we are system we are using. So our system get mature. We are using Amazon SageMaker. All right. So here are some industry use case of for this application. First example is DHL, a global logistic company. DHL use decentralization autonomous robot in their warehouse. These robots do not wait for one central system to control them. Each robot acts independently, communicates locally, and moves shelver or begins in coordination with other. This removes routing conflicts inside dense warehouse spaces and improves efficiency. According to real operation results, this system achieve around 25% faster order processing and about 30% reduction in idle robot or fleet time. The second example is Lockheed Martin, working in defense and aerospace. Their F-35 jets and UAV drones swarm use cooperative sensing and tasking, means each multiple aircraft and drones share mission information, detect targets, and assign roles without overloading one controller pilot. Mission roles like reconnaissance, strike, and support distribution across agents, reducing pilot and increase autonomy. This design make this mission more flexible and more survivable because of its one unit fails, the swarm still complete its objective. The real outcome is increased mission flexibility and survivability, and a system that adapts better in uncertain environment. So from there, the presentation almost has been over. I have something to show the implementation of this platform
Yes, I
in
would
the
like
code.
to. I would like to see that, please. But during the question answers, the Q&A. But you have 5 minutes to show me a demonstration of how you were able to create this platform. And when I'm going to ask you for a specific, to show me a specific learning objective, how did you achieve that? You have to show me that implementation within your application as well. Okay. So the first thing I would like to see, let me open your file. Show me the Swarm Intelligence Platform architecture and the bio-inspired algorithms that you basically infused in them. So please.
Can you please repeat the question?
So the first thing you have to show me, this is written in your examination topic, right? And I'm reading it from there.
Yep.
It says, in the presentation, you have to show me Swarm Intelligence Platform architecture with bio-inspired algorithms. So show me the architecture. How did you develop the architecture, the front end, the back end, right? Which bio-inspired algorithms you used, so on and so forth. Please.
All right. All right. Let me start this.
When were you given this topic? How long?
Uh, I have given this topic in the September, I guess.
September, October, November, December. So it took you how many months to prepare for this topic?
Uh, it Meanwhile, it took me around 20 days to prepare these things.
20 days. Like a month?
Yep, yep.
20 days, like 3 weeks? What?
Yes, almost a month completely, because after that I have to make presentation like this. So initially I choose some animation stuff in the presentation I have to replace with that. So it took me a month to submit my application presentation.
Okay. All right. Please show me the Swarm Intelligence Platform architecture.
Yeah, just give me. Right. So basically, this is the application from we can assume the user point of view. From here, user can add like an admin. All right, just let me explain. So this is the map of the London city, and I am just right for the moment. I am capturing this type of area, and the information I am getting from it from Sumo, like real-time communication and real-time traffic on road. For that purpose, and I am making this front-end application via React, and the backend is as shown in this architecture. Like these are the microservices which are communicating with each other, and when you deployed on
Next time, please submit like clearer pictures in your presentation. The diagrams are pretty small. You have to submit to me like clear visualization of the documents as well. So I will not be able to complete your exam marking until I see the diagrams in a clear format, in a separate, bigger format. I can zoom in and I can read because in the presentation they're so small, I can't read them properly. So you have to show me something larger. It's okay, but you have to show me something larger as well. I will
all
withhold some of the marks on the side until I see them, right? Okay.
right.
So yes, go ahead, go back and show me the architecture. The architecture is running, okay. Which bio-inspired algorithms you used?
I am using the PSO algorithm, which helps us to find the shortest for the easiest path for our vehicles. And when the system get learn, we will utilize the ACO algorithms. When the vehicle move around in this road, so they will left some marks and store in the DB like this, like that particular edge in this road or somewhere else where the vehicle normally face the traffic or any sort of distortion. So when next time they will trigger the ACO, so it will give the routes to the
Okay, What
vehicles.
what
And
role is the MQTT playing here?
for in this application, MQTT is not working because we need something like real to IoT devices so that vehicle can communicate with each other.
No, no, I mean, I understand you mentioned that in your presentation, but you're saying that you didn't use MQTT in this instance. Is that what you're saying?
Uh, if it says it's my bad. In the production environment, when the vehicle can communicate with each other, so they use MQTT or IoT devices to communicate with each other to share local routes, local paths. So even though if system get offline, so they can make decision on their own.
Okay, if you are there and if you can do this after the exam, immediately you have to submit me clearer diagrams. See, in this is your presentation I have. I can't see. I can only assume telemetry MQTT, right? OTA job. This I can't read. Can you read this? I mean, I can't, right? And I'm zooming it through. This is an API gateway. This is the Cognito, Auth, NewZ. These are the questions I have. I can't read this diagram. So please, when you submit the diagrams need to be submitted separately in a clear format that I can read. If you can't read, I can't read, right? So that's something I'm telling you right now. You can stop the sharing of the screen so that because we are now jumping into the Q&A part, okay? All right, so Bismillah ar-Rahman ar-Rahim. So let's start in, and I'm going to ask you the specific question. Then you have to show me back how you were able to deduce all of these things. Okay. All right, Bismillah. So why is decentralization, right? Why is decentralization a core requirement in swarm intelligence? Why?
Well, the core principle of swarm intelligence. I will start explaining with the example of the birds. Like the birds are flocking in the sky. So if some bird or someone else identity in of them is get lost or maybe don't want to proceed, the swarm will move towards its direction. So decentralization means the application will not be scalable in the best times, or if the one mainframe system will fall, the all system will fall. So that's why decentralization is preferred in the swarm intelligence.
Look, it's a good academic answer, but you have to give me a proper answer like this. So for example, you did mention that if in a centralized, if one thing falls, everything falls, right?
Yep.
Okay, that makes sense. But you have to say The question is, why is decentralization a core requirement in swarm intelligence? You have to explain it like this. Decentralization removes single point of failure, right? And allows agents, vehicles, or robots, in my case, the presentation I'm presenting, to make local decisions based on real time conditions in logistics, where traffic, as I demonstrated to you, order volume, disruptions are dynamic, centralized routing systems become brittle. They can easily break. Decentralized swarm agents continuously adapt, redistribute tasks, and self organize, resulting in high resilience, faster recovery from disruptions, and improved fleet utilization. Right? This is how you have to explain to me the topic. Because when you go, in your KYC, it is mentioned you want to go to US, right? In the US right now, a huge amount of work is being done on this thing alone. You know, warehouse companies, logistic companies, delivery companies, uh, what is happening on the warehouse, floors. Um, they are removing some of the regulations and they are proceeding aggressively towards the innovation of drones and all of these things. So they're looking for engineers like these who can troubleshoot, who can find out the issues, and who can go in, right? So you can play a vital role, but you have to explain yourself in a way that it resonates with them. Okay. So remember, this is very important for you. You have to go back and do the Ar-Razak labs. In your Ar-Razak labs, sometime in the next March, April, you will find the whole project that you delivered here to develop over there. You will have the resources and everything. You will even have the CUDA resources as well, right? So that you can optimize and get all those things done. But it needs to be answered in a proper fashion. So why is PCO, ACO, you know, chosen instead on relying optimized algorithms? I mean, why are you choosing these two algorithms? Why not something else?
Well, well, when we look into PSO algorithm and ACO algorithms, we have exactly the exact definition from the nature. If we see ant colony, these algorithms are basically bio-inspired. So when we see over the ants, no matter what happen, they always choose the shortest path to their location. Even though if we see their houses underground around the earth, they will always choose the shortest path to their destination. So they left the Ferrom type of thing, which other ants can follow. So this is the best use case of ACO in the logistics. And for PSO, in the when the birds are flocking in the sky, no one is the main leader. Everyone is moving around their own experiences, and for using their experience, they reach to their destination. So from this particular behavior, the whole emergence behavior can came into, and the system get mature. So by looking at these two algorithms, so they basically very well fit for the logistics. So
Okay.
if we compare into logistics, if some vehicles are moving from one place to another, and let's say one vehicle is facing some issue meanwhile on the roads or somewhere at particular area, so as like ants, they left Ferrom on the road, we can mark as Ferrom and we save into our DB, and after that our system get learned, and
Uh,
next time vehicle.
pheromones. You
Pheromone.
saying ferron. I sound like who? Right? Pheromones is like they leave a scent,
Yep.
right? So, okay, since you're a Muslim, I can ask you this question. Name me the surah which is named after the ants in Quran and the bees.
Mm.
Yes,
So let me.
you're 26 years old, right? MashaAllah, right?
I'm just getting a remind.
Okay, name the surah which is named after a cow.
So,
Okay, what is the second surah of the Quran?
Surah Fatiha.
That's the first one. The second one.
Surah. Let me.
Surah Al-Baqarah.
Surah Al-Baqarah. Yep, I was. It is the longest I was.
So you really, see, Muslims really have to work really, really hard. Al-Nahl, Al-Namal, Ankabut, Al-Fil. There are many things mentioned in the Quran, right? So we really have to work really hard. All the inspiration is there for us to be driven from the Quran, right? When I was designing these labs, if I tell someone I was using the inspiration from Quran and Hadith and from the historical books, they will scratch their heads and say, like, what were you doing? And I said, this is how things work. You see? So the reason I became a director and a C level at a very young age, was I was not following a traditional path of engineers. I was able to connect the dots while sitting in front of the management by explaining things in the most basic fashion and connect the dots by using examples from nature, by using examples from daily lives and stuff like that. And where was I getting all this information? If I tell someone from Quran and Hadith, they will again scratch their heads, right? So this is a difference. So if you really want to go and proceed, you really have to look into the Quran and the Hadith. And there's a wealth of information out there for you. And this is what makes you into a great engineer, into a C-level executive. How to connect the dots, how to talk, how to communicate, right? Okay, so in your architecture, you showed it to me. Explain the difference between development architecture and production architecture. I mean,
Well,
what is the
in
difference like? You
well.
mentioned something.
Well, in development architecture, there is one core thing which is missing. In production, in development architecture, there is one core thing is missing, which is the communication between the vehicles on the road, and the one a main thing in the production development we have the real time orders, real time scenarios, real time data facing. Let's say in development I'm using Sumo. Basically, Sumo it's like a recording of for minutes, hours,
Stop
in which
here.
we.
Stop here. Start again. Give me the answer again.
Okay, just give me a minute. uh, there's a big difference in a development and production environment. I can say there are two main core things. First, in development, I don't have the real-time communication between the vehicles,
Okay.
as it is much not needed in the development mode. For that purpose, I really have to need the real-time vehicles, IoT devices on the road. And second thing, which is the production have and the development did not have, in the production, I am having the demo orders and the demo simulation of the roads. I'm using Sumo for that purpose, because in Sumo we have the recordings kind of stuff. So in the production mode, I am facing real-time traffic, real-time thing. But the comparison is between is that on Sumo, if some traffic got stuck in that particular point, so my system getting mature as like in the production.
Okay. So explain to me PCO, ACO, right? What's ABC?
ABC derived from the bees. It is the Firefly algorithms. This algorithm could be very useful for that particular case when, let's say, in logistic scenario, on day starts, all vehicles are moved from the depot station and they are midway in the city in between. Somehow, a very crucial order came into place, and I really want to deliver that order with the high priority. So instead of calling that vehicle to my place, I will choose dynamically using ABC algorithm, which is derived from bees, because they choose dynamically flowers from that point. So this algorithm will help to assign me the nearest or the best vehicle for that particular order.
Okay,
The
so what about EFG? EFG algorithm.
AFG algorithm,
EFG.
EFG.
There's PCO, ACO, ABC. There's EFG.
Uh, Sorry, sir, I don't know about that. I
Okay, that was just a twister to check. There's an algorithm known as the element-free Glaricon, right? It's the method of numerical, basically technique used in path optimization. So we use that as well, right? So that thing is also there as well. It's used in mechanics and engineering, computational mechanics and engineering, right? Something that I have developed the labs on. That's why I was just throwing out a lab question to see if you are just reading a screen or what. Okay. All right. So the other question I have is, so this is the last one, what is the emergent behavior and how does it manifest in the logistic use case?
Emergent behavior is like that systems learn from its neighbors. Like let's say I will give you the scenario. Let's say I am driving the vehicle and I am delivering the parcel. Right now I am stuck in Liberty Chowk at Lahore, and another vehicle is passing from nearby, we can say that Model Town or somewhere else which is near to the Liberty Chowk. Right now I am stuck at Liberty, but what benefit get the other vehicle which is passing from that place? If the other vehicle is passing from that place, it will also get stuck. So emergence behavior, it's mean like system get mature. If I'm facing some other trouble, the other person will not get that trouble. As like in the birds, when they are moving to somewhere else place for eating food, let's say no one else know about where is the food is located, but let's say every bird in this in that particular swarm, in that every flock know some little information about that. So let's say every bird moving in some direction and everyone following that behavior, so at the end of the day they will get food. So this is the emergence behavior, like the system learns from its neighborlyhood things.
Like there are so many verses in the Quran which talks about all of these things, right? So many signs. In the Quran, Allah has mentioned Namal, the ant, Ta'ir, bird, Jamal, camel, crow is Gharib, Baqara, cow, Hudhud, hoopy bird, which is something that Sulaiman alayhi salam has mentioned. So many animals have mentioned, like there is cow, there is whale, right? All of these things, and bees, insects. And when you read about their lives, there's a hadith, a very famous hadith, Al-Bahiqi uh, said, it is supported by him. Um, I remember part of it. Rasulullah sallallahu alaihi wasallam says, reflect upon the creation of Allah, but do not reflect upon Allah Himself. You know, pay attention to the creation of Allah because we can only pay attention to the creation of Allah and can visualize, but we cannot visualize how Allah looks like. How is He? Is He sitting on His throne? Is He standing? What is He doing? That's not part because He's beyond the imagination, right? But like when we pay attention to the surroundings, we pay attention to all of these things. All the things that you had mentioned, PCO, ACO, ABC, EFG, all of these are different algorithms, right? And these different algorithms gives us like all the deep insights about how we can develop a continuous feedback system, uh, how all of these things are working. You mentioned birds, you mentioned all of these things. In our cars, we have these new technology. When we use Google Maps, Google Maps uses these things, right? Swarm
Yes.
intelligence. So if you're driving on a Google Map will say, there is a possible roadblock ahead. Avoid it. Take this route. You mentioned you're stuck in Liberty Choke. The other one is going from some other place. He will get a message saying, don't come to Liberty Choke, right? Avoid that pathway, right? Similarly, the birds have the same thing. They have developed the same things. It is mentioned, Rasulullah sallallahu alaihi wasallam said, the birds and the animals will be the first one to distinguish. when the day of judgment will be coming. Friday is the day. So on the day of Friday, all the birds and the animals are very concerned. They are very deeply concerned and deeply disturbed, like this might be the day. And Rasulullah sallallahu alaihi wasallam said, except the humans, the jinn and the ants, they have no worries, right? So they are celebrating their days, they're doing this, they're doing that, watching the fireworks, right? At night time, when the Jummah has started after Maghrib Salah and they are celebrating. See, Ajib, right? So you have to pay attention to all of these things. There are lessons for us. As a Muslim, I'm giving you these examples because this is going to help you, inshallah, down the line. Okay, so this thing is over. The first uh, 5 questions are over. You secured 9.5 out of 12.5 in the Q&A in the first 5 questions. Good marks. Okay, mashallah. I'm telling you this so that you can position yourself. But now the gloves are off, and you're going to go and do some mat time. I do. We'll do some of that. Okay, so now let's jump in, and I'm looking at a presentation. So I'm going to give you a scenario. This is a diagram, looking at your diagram, right? If 20% of the swarm agents fail mid-operation, how does the system recover without human intervention that you have designed?
It really depends which components which you are talking about. If we say the PSO algorithms and
The swarm agents are failing. What happens? Mid-operation, they are failing. 20% of them.
there's one thing, the our all system will not collapse at all. Let's say uh, uh, I'm assuming like I have a swarm agents like ACO agent have been shut down, PSO agent have been shut down. Other agents are working. So in that particular case, our the platform will not fall, and that particular things will not be in working. And when they got enabled, the system got balanced.
So what kind of, you know, you mentioned pheromones, you mentioned all of those things. I mean, if the system fails, 20% of the agents fail, there is no pheromones data coming in.
Yep.
You haven't answered the question completely. Like, how do you recover? What do you do? You
Well,
mentioned some
if
of
I
the things in your initial in your initial presentation.
Well, if we say like the ACO algorithm and PSO algorithm has been dropped, but we are assuming like our vehicles on the road is currently are working, they are also storing the information at that point what they are facing. So when the system got recover, we can retrieve information from then the from if whatever the thing starts to be we'll retrieve
Okay.
information from that.
So the answer is, I'm going to give you the answer, right? That if the remaining agents detect reduce pheromone signals or missing state updates, then they will automatically redistribute the tasks. Self-organization and stigmery allows the swarms to rebalance the workloads dynamically, maintaining operational continuity, right? Of the as per the architecture. Was the answer I was looking for. Okay, scalability questions, right? Let's go into the scalability question. Um, what architectural constraints emerge when scaling from agents to 100 agents to 10,000 agents? Go ahead.
So can you please repeat the question?
What are the architectural constraints that can emerge if you scale from 100 agents to 10,000 agents? I mean, if I look at your architectural diagram, right?
Yep. Yes.
What architectural constraints are there? I need to scale this thing from 100 agents to 10,000 agents. What will happen?
Well, uh, we are using here Kubernetes. So everything if we see into the architectural diagram or everything is zooming into containers. So when the spike rises, the Kubernetes actually we are using it will the increase the number of containers, and after that sometime the spike or threshold came into place. So these number of containers reduces into small number of containers which we define which our total need.
Uh, well, the best answer, if I look at your, architecture, the key constraints include, in my view, looking at your architecture, message congestion, because there's an MQTT pipeline going on, state synchronization overhead, memory growth for pheromone trails, convergence latency, because now all the data needs to converge from 100 to 10,000. These can be mitigated because I ask you what are the constraints and how would you address them, right? So these can be mitigated through, as you mentioned, Kubernetes, hierarchical swarms, regional partitioning, asynchronous updates, right? And bounded memory strategies. We are facing this thing, and that's why we were using, are you doing a Razak Labs?
Yes, I'm part-time doing Razak Labs.
So in our Razak Labs, we have seen that when 10,000 containers are open, we start to see a bottleneck, right?
Yep.
And some of the containers drop. Some of the students get impacted. So what we did was we deployed DCV server, Amazon DCV server, right? It's a protocol. Now we can scale to 1 million containers, 10 million containers, the maximum we have tested, right? 10, so imagine launching 10 million EC2 machines and then bringing them down. This is scalable architecture. There was a bottleneck that we identified, which was our guacamole server. So we have to remove it and put the new technology in there. But now I'm asking them that I need web RTX protocols and some of the other things to see how we can expand, right? So when you go out for the interview, scalability questions will always be asked. Security questions will always be asked. Architectural questions will always be asked. Restraints and limitations of the architectural questions will always be asked. Compliance, GRC issues will always be asked. Data privacy, right? No amount of certification prepares you for these things except the labs. So that's why you have to go in and spend time in doing the labs because that will prepare you to sit in front of the interviews. Okay. So I'm going to ask you these interview related questions now. How would you prevent a malicious agent from poisoning swarm intelligence decisions? How would you do that?
Well, there is a protocol name which is I am just there's a protocol name which
Just
is
before
not
just
coming.
before coming here, just before coming
Yep.
here, our team was testing the DCV server in production, right? In staging.
Yep.
What they saw was that one of the URL of the lab, if a student launches a lab, the lab comes in, the new mechanism, not the old lab mechanism, but the new container comes up very fast. It takes 1 minute because we have to run so many checks and everything. But then they found out that the security testing found out that they can copy the URL, the authenticated URL, and two students can run the same container. So the other student can see what you are doing in your container, right? That is not allowed as per the policy, right? This can create basically poisoning of the URLs, right? So I told them you should have authenticated the URL with the student credentials as a one-time token, which is attached. So if someone else try to copies that URL, it has a one-time token. It doesn't work. Only that person can use it, right? So I've given you some good answer now. So how would you prevent malicious agents from poisoning swarm intelligence decisions? Someone is trying to put in poisonous data. This is something that could have been done in our system by impacting our students' records. So if you're doing your labs and you're saying you're passing all the labs with good marks and everything, and someone attacks our platform and they start poisoning the data by inserting Arslan Ahmed hasn't done this lab, has messed up this lab, has messed up this lab, when you have in fact completed. So one uh, record is showing you completed the lab, the other record is showing the lab you didn't complete it, right? So that's poisoning of the data. In our system, you can't do it. See, this is the amount of things we have to do and deal with. Similarly, as I mentioned, you have to deal with this. So how would you prevent malicious agents from poisoning swarm intelligence decisions?
Well, when I see in logistics, my individual cars will also act as a swarm intelligence agent. So there's one protocol name which is not coming into my head, which is also mentioning in my presentation a topic, which after when we implement that, there is a thing when I communicate with you and you communicate with me. So I can authenticate who am I, and you can verify that the person who are saying is at who. So it's some like stuff like CSA encryption like stuff. So in Swarm Intelligence, in my case, if I take about certain amount of agents like the cars on the road, so when one car communicate with another car, so we may say that we have some sort of hash. After validating that, we can allow communicate one car with another. So from that way, we can stop poisoning information. Like say, if another car is joining our agent systems and say that this road is open, this road is open, this road is open. So my other car, until unless it's not validating that car, the car is along belongs to that my company or that stuff. So till that now, it will not accept information. And moreover, in this, if we say in the database
The
integration, if
answer was very simple. You mentioned the word authentication in there by, I think if I have to path your answer, you're going and surrounding, moving all the places, sab jagah gaadi chala rahe ho udhar udhar, and then you coming back and say this is the answer. That's not the right answer, right? So and this is not you, this is part of the system, how which you were raised up in the educational system. You need to give some kind of answer. Lamba lamba answer likhte chale jao, keep on writing, right? So no, by implementing agent authentication, trust scoring, anomaly detection, consensus thresholds. These are some of the things that we can employ. Plus, agents contributing anomalous or inconsistent data can be downweighted or isolated, preserving swarm integrity. Halas, like it's a very simple answer. This is about security and trust. Two topics, right? I give you. So you got some score. I'm going to give you some score because you mentioned some of the things here and there, but it has to be a good answer, right? Okay, so uh, so now you are standing in front of, a VP. How would you explain this system that you have created to a non-technical logistic executive? So I'm completely non-technical, right? I'm completely non-technical. I just did my MBA from Wharton Business School and now have joined in and I'm working as a VP of this logistic company, etc., etc. You know, I have connections in big places. I've seen these kinds of people working in the industry, right? So, how would you explain this system to me? And I'm a non-technical logistic executive.
uh, well, I'm assuming that you own a TCS company right now. So I'm explaining to you how this platform can help into you. So, well, let's say you have company and you have multiple depot station around the city and around the country. The things which are you facing that your deliveries are not getting successful. You are facing like fuel consumption problems, and you are not able to utilize your fleets of vehicles properly, and you really want to achieve the efficiency in your system. So you can definitely get look into my system and how my system can get help into you to achieve these things. So in my system, I am using some protocols or algorithms which are inspired from nature, and these algorithms which are I'm using is not developed by any human. These are proven and well working in the environment for millions of years. So let's say you have
You answered the
number.
question. That's it. And don't go too much detail, but don't say millions of years, this and that, right? So here's how you have to answer. Okay. Bismillahirrahmanirrahim. So I'm looking at your scores. I need to see. So you say it, I ask you, explain to me this whole system that you have developed, and I'm a non-technical logistical executive. Why should I look into your system? So you will say, the system I've designed, it replaces the rigid route planning with a self-learning fleet where each vehicle continuously adapts based on collective experience, resulting in faster deliveries, lower cost, and high resilience without manual reconfiguration or intervention or anything. Boom, khalas. This is the answer. I'll say, oh, you mentioned some of the keywords. Lower cost. Yes, I need to lower cost. That's my KPI as the executive. Faster deliveries. Yes, I gotta make sure our delivery is faster. So I will say, you know what? Okay, Arslan, I'm going to hire you. Go and do it. Because if you do your job, I can show my numbers. I'm increasing the company profitability. Because you mentioned lower cost of fuel, this and that, all of those things, right? But it needs to be visualized properly. Okay, you need to give proper answers.
Yeah.
Okay, inshallah. So that's good. I give you out of 2.5, 2. Okay. All right. So let's jump in. So this is a very good one. Lahore is always congested, right? So let's talk about Lahore or Karachi or whatever, right? So a city, Lahore city introduces sudden vehicle restrictions in multiple zones, right? How does the SWAM respond faster than centralized systems?
Sir, I'm sorry for this. Just repeat the question one time more again.
So,
Like,
Lahore, Mariam Nawaz comes and says, we are going to implement uh, multiple vehicle restrictions that cannot enter in these zones, right? For whatever reason, they're trying to restrict PTI rallies or whatever, right? They're doing that, right? This is for all the PTI guys who are sitting out there trying to plan out all the things that they want to do. So they can take it from there, right? And the military is also planning that yes, we need to support the corrupt government or whatever so that we can support ourselves, right? Whatever the case is. And they are trying to create restrictions. So they're saying, let's introduce sudden vehicle restrictions in multiple zones. पुलिस को लगाओ बोलो कोई गाड़ी यहाँ पर इंटर नहीं होगी ठीक है ना so they are putting barricades and all of those things. How does the swarm respond faster than centralized system? What happened, how because PTI can use create an app that just like you have, and they can start using it to share intelligence. Every mobile user is now a swarm agent,
yep.
and it is sharing data. Oh, Gulbarga का चौक बंद हो गया. Gulbarga का कोई चौक है वहाँ पर? Is there any Gulbarga चौक? I don't know. I don't know about law. I'm just making this up. Is there anything? Gulbarga
Uh,
चौक or
Liberty Chowk is
Liberty
specially
Chowk,
working.
whatever, right? So you say, I think Gulbarga is in Karachi. So I don't know a lot about these roads. So that's why I said like if I make something up, I have to ask you. So Liberty Chowk is banned. It's closed, right? Don't go there. So we have to. So everyone is sending data, right? And all these PTI youngsters are sending data. It's now fight against establishment, corrupt politicians. Corrupt politicians was never a problem. They were always there because they are used by the establishment, right? So they're using that and et cetera, et cetera. So how would the why is this swarm intelligence better than the centralized intelligence? Why is it better?
Well, you can't answer. Uh, you can't answer this in your question. Like in the Swarm Intelligence Agent, a Swarm intelligence platform, every agent is working like an agent. He can deliver input, and the system get mature. In centralization system, if I'm assuming a monolithic application, all right. So if my application goes crash, all system get crashed. Like if my in my application, I have authentication system, ordering system, and something like a buying system. So let's say due to bug in my buying, like adding card system or purchasing system, that service goes. So in monolithic application, or we can say in the centralized system, all system got crash. But if we say in the swarm agents, in that particular case, if one agent goes down, two agents goes down, three agents go down. Oh, okay, let's say if I'm assuming like at Liberty Chowk they put the call jammer at their signal jammer, everything happen, everything signals got shut down, but all the surrounding people can share information. So by putting the jammers right there, say so they don't get much effect to the like PTI, because from information from other sites, it getting transferred from there.
Good job. PTI guys, take some notes. Yeah, he can work for you guys if you want to offer your services. Okay. Okay, good job, mashallah. Good job, good job. Very good exam, mashallah. Okay. I'm just putting your scores in. Just wait with me. How was your exam?
Mm. It was great, but it was not as I suppose it will go. I'm facing
Could
some
have been, could have
communication
been, could
issues.
have been better. Could have been
Yeah.
better. Like, I mean, it happens. It happens. But that's okay. That's okay. You did well, mashallah. Okay.
Thank you, sir.
Okay, mashallah, good. Bismillah ar-Rahman ar-Rahim. So this is my feedback for you. In your presentation, you secured 21 out of 25, mashallah, which is 84%. You were able to demonstrate all the things. Some of the things were missing. You will find them in the report that I'm going to write it down afterwards, inshallah. I took all the notes and everything. In the interview, you secured 19 out of 25, right? You missed some of the opportunities. The answers were a bit academic, but it was okay. Um, all in all, in the interview, you secured 76%. The final score comes out to be 80% if pass with merit, mashallah. Okay, so that's good. So that's a good start for you uh, in terms of passing this exam. So my question is, what do you want to do? When did you join a Nafe, first of all?
Yep.
And how did it help you? Did we help you in any way in your career or something like that?
Yes, it helped me in my career, and it really helped me to in my designation as well. I really don't want to share my salary here, but from you can say I got 100% raise after learning some DevOps skills, and it really helped me while getting to other interviews. Because before that, if I say about the like DevOps stuff, so there is one thing in my mind, like if I do AWS certified developer, AWS certified DevOps engineer, so I am
That
the
doesn't,
DevOps engineer, but that's totally fake. I really know about the worth about how cybersecurity play a role in it, how other PCI DSS and other stuff have really impact on that. How
there's a thing. I'm going to stop you there. I know you started praising. I don't like the praises of us hearing. For me, other people they like to hear it, but I don't. Right? There's a dua of
well,
Rasul. There's a
these
dua of
are the things
Rasulullah
which I
Sallallahu Alaihi
really
Wasallam. No,
impact
no,
to me, and
I understand.
my
I understand, but there's a dua of Rasulullah Sallallahu Alaihi Wasallam. Alhamdulillah lazi bi ni'matihi tutimmu salihat. All praises belongs to Allah, from whom good things are accomplished. I haven't done anything. I don't want to be remembered as Muhammad Faisal, who started An-Nafi. An-Nafi is the name of Allah. All of our patents, Al-Bari, is the name of Allah. An-Nafi is the name of Allah. Al-Bathit, the geofencing awesome intelligence platform that we have developed, is the name of Allah. Ar-Razak is the name of Allah, our job placement program. Al-Qawi is the name of Allah. So whatever we are doing, right, it is done for the sake of Allah, right? 60% of the profits of the company goes towards the path of Allah, right? In doing all the things that we're doing. So I understand we help you, alhamdulillah, but you have to go and talk to other people about regarding this. This is something you can do and share it. Now, this is my thing. Many people come and they say like we were here and then we, alhamdulillah, we achieved this, and as you mentioned, 100% raise. That's good, mashallah, right? I have seen people. I mean, whatever you spend, what is the ROI? How fast you were able to get all that money back? This is the key question I would like to know.
If I say, if any person doing this stuff with dedication and total ईमानदारी के साथ, I really want to say with that.
Yes, this is very
So,
important.
he and one and the most important thing, the labs. Seriously, the labs are really great. I cannot emphasize it. If you may stop me here, so I won't stop at there, because the labs are
Will
really
do.
good. I would say the course is on separate sides and the labs are gems. I have some development experience, and I really can say with experience the labs are gems. So they really help me in that journey. So come to the answer. If someone spent really 8 to 9 months with dedication, after spending 4 to 5 hours per day, so after that, if he really consume all the knowledge, I could say he would go to 4 to 5 lakhs per month. Seriously.
Yes, that's true. Okay, so Jazakallah khair for your response. Now, here's the thing what you have to do, okay? Uh, Multiple students are going to USA and they have gone to USA. Multiple students have gone to UK, right? Uh, and these are increasing in double digits, triple digits now, right? Because everyone is leaving and they want to go outside, right? This is my recommendation for you. You have completed this. You have good intelligence in terms of development part. You are already a developer.
Yep.
You were a small developer now, but now you have developer expertise in cybersecurity and DevOps and SysOps and AI and all of these things. And you can see there is no limit to what you can do, inshallah, right? So if you want to go for apply for EB2 visa in USA, that's one thing you can do. If you want to go and apply for global talent visa, that's another thing you can do. You need to pass Kubernetes exam. They are very easy. Passing Kubernetes exam doesn't mean you will become the best Kubernetes guys out there. No, I mean, passing exam is very easy. You can memorize the dumps and do all of those things and you can do it. But when it comes to the interview, that's the different part. But that title will take you there. तुम्हें जो title मिलेगा ना क्यूबिनोटिस का क्यूबिनॉट्स का जो मिलेगा एंड गोल्डन
Yes.
क्यूबिनॉट्स का वो तुम्हें इंटरव्यू शीट पे बिठा देगा.
Yep,
मेरे
I
पास
just bought the bundle for that
हाँ
a month ago.
राइट नाउ अभी स्पेशल सेल में है ना.
Yeah,
तो
50% off.
हाँ जाओ निकाल लो एग्जाम, जो गो एंड पास द एग्जाम्स, राइट, एंड देन अप्लाई फॉर अ मास्टर्स डिग्री इन यूएसए, right? Search a university where you don't have to go for GRE or GMAT or anything like that. ठीक है. सर्च फॉर यूनिवर्सिटी के जो AI में दे रहे हैं ड्रोन्स ऑटोनमस सिस्टम्स, ठीक है ना इसमें.
So, sorry, sir, what you repeat early, look for the universities which are accepting GRE.
No, they don't ask for GRE or GMAT, right? You don't want to go for GRE GMAT because that will take you 3-4 months back in doing the preparation, right? There are many universities that can offer you without that. Duolingo का English test करो, they accept that. All the US universities accept Duolingo English test. It's cheaper than IELTS. IELTS से ज़्यादा cheaper है. Okay. The other thing is national waiver, जिसके अंदर है यूएसए का नेशनल वेवर ड्रोन्स के अंदर है, ऑटोनमस सिस्टम्स के अंदर है, एआई के अंदर है, ठीक है. वो तमाम फील्ड्स क्वांटम कंप्यूटिंग के अंदर है. दीज आर द फील्ड्स. गो एंड डू अ स्पेशलाइजेशन. स्पेशलाइजेशन करो. When you do the specialization, you will be a person that you can become, Arslan Ahmed, no? You can become like Tony Stark, the Muslim Tony Stark, not the Bad Tony Stark, a playboy, no, but a Muslim one, right? Bolo, I'm a halal Tony Stark, not the the bad person Tony Stark, right? So yes, you can become that, inshallah, right? My son started reading all the DC and Marvel comics, right? पढ़ता रहता है वो, कि मैंने उसको बोला भाई तुम्हारी तो पहली इंग्लिश अच्छी है, तुम यहाँ पैदा हुए, मैं तो तुम्हारा बाप तो पाकिस्तान में पैदा हुआ था यार, तो उसकी तो इंग्लिश सारी ठेलों के ऊपर खड़े होकर मैं कॉमिक्स पढ़ रहा होता था। दैट्स हाउ आई यूज्ड टू डू, राइट? तो मैंने उसको बोला भाई ठीक है, अच्छी बात है, उसको अच्छे लगते हैं। मैंने कहा ठीक है पढ़ो, कोई मसला नहीं, लेकिन मैं उसके साथ पढ़ता हूँ, मैं पहले स्क्रीन स्क्रीन कर लेता हूँ कोई इसमें गड़बड़ चीज़ तो नहीं है, ठीक है ना? सो दैट्स समथिंग आई डू। सो यू कैन डू दैट इंशाल्लाह। ड्रोन्स, quantum computing, robotic process automation, nanotechnology, you can choose anything. My view, looking at you, looking at your background and everything, robotic process automation, quantum computing, ठीक है ना? These are the principles, ये वो चीज़ें हैं और कि जो तुम्हें बहुत आगे तक यूएसए में लेके जा सकती हैं, ठीक है ना? 2026 तक H1B के ऊपर पाबंदी है, 2026 के कुछ टाइम तक, ठीक है ना? जिसमें उसने $1 लाख की फीस रखी हुई है कि कोई भी H1B स्पॉन्सर करेगा तो तुम्हें उसको इतनी फीस देनी पड़ेगी। दैट फीस राइट नाउ बीइंग चैलेंज्ड बाय कंपनीज इन द स्टेट्स। ये चीज़ हट जाएगी, दे विल रिमूव इट बिकॉज दे नीड द टैलेंट, दे नीड द पीपल। बट तुम्हारे पास EB2 वीज़ा है, यू कैन अप्लाई फॉर EB2 वीज़ा, कम हियर, डू योर मास्टर्स, build up your profile, start teaching at a Nafi. अब Abur Rahman का मैं प्रोफाइल बना रहा हूँ, आई एम हेल्पिंग हिम आउट, सो आई कैन हेल्प यू एज वेल। आई कैन हेल्प ऑल द स्टूडेंट्स whoever comes to me and say कि भाई मुझे भी EB2 वीज़ा अप्लाई करना है, आई वांट टू स्टार्ट टीचिंग हियर, स्टार्ट प्रोवाइडिंग योर सर्विसेज, यू कैन डू ऑल ऑफ दोज थिंग्स, ठीक है ना? दिस विल हेल्प यू, दिस विल टेक यू फर्दर इंशाल्लाह, and this will develop you, and this will help you because you need to build up your profile. Yes, I've been teaching at Nafe, I've been participating here, I've been doing this, I've been doing that, and all of these things will make you a very valuable commodity, a very valuable person in USA. And while you're in the US completing your degree, ठीक है, तुमने देखो पूरा बैचलर्स स्किप कर दिया, तुम्हारे साथ जो लड़के जो थे कॉमसेट में थे, फास्ट में थे, जो भी जहाँ जहाँ भी गए, वेयर आर दे स्टिल स्टडिंग, अभी तक पढ़ रहे हैं ना? यूर ऑलरेडी ऑन द जॉब। उनमें से कौन है जिन्होंने ग्रेजुएट किया और वो जॉब पे बैठे हैं? वो क्या उनकी सैलरी तुम्हारे बराबर है?
They are less.
वो भाई वो बोल रहे हैं यार ख्वारी हो गई, ख्वार कर दिया सब कुछ यार, बस हम लोग बस गश्त करते रहे, ठीक है ना? दिस इज द प्रॉब्लम। सो यूर ऑलरेडी स्टेप्स अहेड। क्यूबी एस्ट्रोनॉट करो, गोल्डन क्यूबी क्यूबी नॉट्स करो, गोल्डन क्यूबी नॉट्स करो, और उसके बाद साथ साथ अर रज़ाक करो, रोबोटिक प्रोसेस ऑटोमेशन, क्वांटम। यू आर यंग, यू कैन होल्ड दैट। एंड ड्रोन्स, ड्रोन्स एक स्पेशलाइजेशन पहले पिक करो, उसको करो अच्छी तरीके से, दूसरी स्पेशलाइजेशन पिक करो, उसको करो। यू विल लर्न ऑल द ऑपरेटिंग सिस्टम्स, ऑल द स्टैंडर्ड्स, ऑल द फ्रेमवर्क्स, सब चीज़ें। यहाँ पर पागलों की तरह तलाश कर रहे हैं लोगों की ज़रूरत है, एंड यू विल बी द वन। सो द कंपनीज विल पे फॉर यू। द रीज़न ये H1B के ऊपर तमाम चीज़ों के ऊपर रिस्ट्रिक्शंस लगी हैं, मैं बहुत सारे लोगों को जानता हूँ जाली पैसे देकर H1B निकलवाते हैं, ठीक है ना? इससे जो ईमानदार लोग होते हैं उनको नुकसान होता है। एकेडमिक डिग्रियां ख़त्म हो रही हैं, एकेडमिक क्वालिफिकेशंस आर गोइंग अवे। जिस हिसाब से चीज़ें, टेक्नोलॉजी चेंज हो रही, सब कुछ हो रहा है, एकेडमिक चीज़ें पीछे रह रही हैं। कुछ ऐसा 15-20 साल देखो, यूनिवर्सिटीज़ नहीं रहेंगी, दे विल गो अवे, ठीक है? जिस हिसाब से AI सब चीज़ें आ रही हैं, टीचर्स खतरे में, नुकसान में। दे आर ऑलरेडी रियलाइजिंग ऑल ऑफ दिस थिंग, इट्स राइटिंग ऑन द वॉल, ठीक है ना? सब जगह लिखा हुआ आ रहा है। जो इग्नोरेंट है उसको पढ़ना नहीं आ रहा, राइट? वो नहीं पढ़ना चाहता, नहीं देखना चाहता। बट यू फॉलो द पाथवे एज आई एम टेलिंग यू, इंशाल्लाह। सो वेरी गुड, दिस इज गुड परसेंटेज, यू पास द एग्जाम, यू कैन अप्लाई फॉर सम ऑफ द बेस्ट यूनिवर्सिटीज। अपने हिसाब से बोलो भाई मेरे पास पैसे जमा हैं, सब कुछ है, कुछ माँ बाप स्पॉन्सर कर देंगे, कुछ हो जाएगा, सब कुछ हो जाएगा। बिल्ड अप दैट थिंग, गो टू US, बैकअप कैनेडा, गो टू UK, बैकअप कैनेडा, US, राइट? ग्लोबल टैलेंट वीज़ा के लिए अप्लाई कर सकते हो, सबके लिए अप्लाई कर सकते हो, लेकिन तुम्हें प्रोफाइल बिल्डअप करना पड़ेगा। उसका प्रोफाइल बिल्डअप कर रहे हैं ना पाकिस्तान में, उसके इंटरव्यूज़ करवा रहे हैं हम, रोज़ाना इसका कोई ना कोई इंटरव्यू हो रहा है। अब अबूर रहमान का तुम्हारा भी इंटरव्यू करवा देंगे, मसला थोड़ी है। गो एंड डू इट।
Uh, Thank you so much. I'm
वी
really
आर डूइंग ऑल ऑफ दिस थिंग्स, वी आर डूइंग इट फॉर आवर स्टूडेंट्स, ठीक है ना? मैं भी ऑलरेडी एक्टिवली ग्लोबल टैलेंट वीज़ा का एक लड़के का करवा रहा हूँ, हमारा स्टूडेंट है AI ऑप्स का, कर लिया उसने, करवा रहा हूँ। फिर करवा रहा हूँ माशाल्लाह, ठीक है। He's in UK, so inshallah Allah will give you more success. Ask your parents to make parents are alive.
Yes, sir.
Okay, and ask them to make special dua for me. Allahumma inni as'aluka shahadatan fil masjid nabi sallallahu alaihi wasallam. Jazakallah khair for your time. Inshallah
So
I will
there's
talk to you soon.
one last thing which I really wanted to ask. There's another thing which is passing from my eyes. It's actually Germany visa's chance and carte. So the
Can apply. Go after doing specialization.
not
Go after
before.
doing specialization. Then yes, you can go.
Because right now, I was looking into see because after evaluating EduQual, it will give me 4 points, and my age and experience and all that stuff will
You can
put me
go.
into 9 to 12 points, and I'm
You
easily
will have
eligible.
limited time because एक साल का मिलता है ना वो. Then you have to land
Yeah,
on the job, right? So you
yeah,
have limited time. You can go, but before you go, complete robotic process automation, quantum computing.
yeah.
Within 2 to 3 months, you will be on the job. Write it down. फैसल भाई ने कहा है today 1st of January. फैसल भाई ने कहा robotic process automation में specialization करो, quantum में करो. I will be on the job, and then chance काटे visa apply करो. I will be in the job inshallah within 1 to 2 months time. Because
Okay,
your
sir.
portfolio will be so strong that वो German से पूछेगा बोलेगा it's this is the guy. I mean, this is what we need. But you have to be there. Okay? चलो
Okay.
जज़ाकल्लाह खैर सुबहानक
Thank you
अल्लाहुम्मा
so much for
बिहम्दिक.
your time. It's very nice to see you, to talk with you.
Make dua for me inshallah. سبحانك اللهم بحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. السلام عليكم ورحمة